All right, here we go. As promised, solving three variable systems. Again, this could get long as there is quite a bit of detail to keep track of when you do these systems. So if you need to pause the video and take a break, please do so. But please pay close attention to what I'm doing here and how we do it. All right, when you have a three variable system, you have x, y, z, and you'll have it in this system, we have x, y, z in all three equations. When we worked with two variable systems, our goal at that point was to eliminate a variable and solve for the other variable. That was with two variable systems. We did that by creating opposites. So we created opposites. Right? So the two variable system, we eliminated a variable and we solved for the other variable, and then we substituted back in. We did all that by creating opposites. We had those kinds of things. Those two ideas, eliminate and creating opposites, still apply with three variable system. What you do with a three variable system is you use two of the equations to eliminate one variable, and then you use two more equations to eliminate another variable to create a two variable system. So we'll have three variables to start with. We're going to create a two variable system, and then we'll be able to solve for the other variables. So here's how that goes. First of all, we want to look for opposites. Do I see any opposites in the x's, or do I see any opposites in the y's, or do I see any in the z's? And I do. I have opposites. I have a pair of opposites right here, plus y and the minus y. So what we do at this point is we're going to take and we're going to recopy those two equations. So we'll copy them and we'll say that. All right, I have 2x minus y plus 3z equals 13. And I copied the other equation that has the plus sign. X plus y minus z equals -2. When you had a two variable system and you had opposites, you added them together. You're going to do the same thing here. We will add these together. 2x plus x is 3x. Plus y minus y cancels. Plus 3z plus a -1 is going to give me plus 2z. 13 plus -2, that's 11. All right, so I now have a two variable equation. Which variable did I eliminate here? I eliminated y. So to do that right away, I use the top equation and the second equation. I now have to pick another pair of three variable equations and also eliminate y again. So either I'm going to use the top one and the bottom one, first one and the third one, or the second and the third one. To do this one now, what I'm going to look at is right here. I have a minus y in the first equation and a plus 2y in the third equation. These are opposite signs. So that's going to allow me to do some multiplying and some eliminating very quickly. So I'm going to copy the top equation. I'm going to use the top equation and the third equation now. So 2x minus y plus 3z equals 13. And then I copy 3x plus 2y plus 2z equals 13. Top equation has a minus y, the bottom one has a plus 2. The nice thing is I'm going to multiply the top equation by 2. I'm going to keep the bottom equation as it is. When I multiply 2 times this minus y, I'm going to get a minus 2y. So I'm going to multiply 2 times 2. I get 4x. 2 times the minus y minus 2y. 2 times 3z plus 6z. So plus 6z equals 26. All right, now again, I have opposites in the middle. I have a plus 2y and a minus 2y. I'm going to add these equations together. That will eliminate y. So now I have 7x, y's eliminate, plus 8z equals 39. I now have two equations. 3x plus 2z equals 11. 7x plus 8z equals 39. Both equations have a y that has been eliminated. I'm going to create a new two-variable system using these two equations that I just created. So I have 3x plus 2z equals 11. 7x plus 8z equals 39. Now I'm going to use our two variable ideas of eliminating a variable so I can solve for the other. Again, I'm still going to create opposites. Now everything is positive here. If I look here, I have 3 and 7. I can multiply the top by 7, the bottom by -3. Or here's 2 and 8. Well, 2 and 8, they're related to one another. So in this case, I'm going to take the top equation and I'm going to multiply by -4. That gives me a -8 for z, and that will allow me to eliminate the 8's. So then I have a minus 12x, I have a minus 8z, and I have a -44. So now I have the system of 7x plus 8z equals 39, -12x minus 8z equals 44. All right, so I am now going to eliminate. I'm going to add 7x minus 12x, -5x. 8z and 8z cancel. 39 plus -44, -5. Divide by -5, x equals 1. Okay, I have one answer now. I still have two more to find. I have to find an answer for y and I have to find an answer for z. Since I have an answer for x, I have a two-variable system containing just x and z right here. I'm going to take the 1 and I'm going to put it in place of one of the x's in one of these equations. It doesn't matter which one of these two from the original two-variable system. I'll get the answer I need in the end. So what I'm going to do is I'm going to use the top equation. So I'm going to say I've got 3 times 1 plus 2z equals 11. And now I solve. So I have 3 I now have two solutions. X is 1, Z is 4. I'm now going to go back to the original three-variable system, and I'm going to put 1 in for X, and I'm going to put 4 in for Z. Doesn't matter which equation I use. Can you guess which one I'm going to use? I'm going to use the middle one. It has the least amount of work in it. It is the simplest equation, and I should be able to find my answer fairly quickly. So in this case, I have X plus Y minus z equals -2. So x is 1. I don't know y. Minus z, so -4 equals -2. Combine the like terms here. 1 minus 4. Add 3 to both sides. Y equals 1. So now I have all three. So if my final answer will read that I have a solution where x is 1, y is 1, z is 4. And at this point now I'm done. Mentally, yes, you do need to go back and check those. That's how you make sure those are correct. All right, due to shorten the length of the video, I'm not going to do that right now. This has already taken about 8-9 minutes to do the first system, so I'm hoping to speed that up. Yes, I should be going back and checking those mentally. All right, let's go to a new system. Here's another one right here, three-variable system. I have all the letters again. Following that same idea, I want to try to eliminate something. Here are opposites right here with x variables. Got a minus x and a plus x. All right. So for the time being, I'm going to just kind of ignore that top one, and I'm going to add these two together. Negative x plus x eliminates x. Y plus 2y is 3y. Negative z is negative 2z. 6 plus 1 is 7. All right, so now again I got to go pick. I used the second and the third equations. I used these two here to create a two-variable system. Now I have to eliminate x again. Because I've eliminated it once, to create another two-variable system, I have to have another equation with just y and z. So I'm going to use the first one and the second one because I have opposite signs and I can multiply pretty quickly there. So if I have to take this second equation, I'm going to multiply it by 2, and it will change to a negative 2x plus 2y minus 2z equals 6. Make a better x. There we go. Copy the other one. All right, let's add the two equations together. Cancels. 6y minus 4z equals 9. Create the new two-variable system. 3y minus 2z equals 7. And I'll copy the other equation. I'm going to eliminate a variable, so I'm looking at the top equation. I got a relationship between 3 and 6, or negative 2 and 4. I'm going to multiply the top equation, in this case, by negative 2 to create opposites with y. So when I do that, I get a negative 6y. I get a plus 4z, and I get a negative 14. And if you're looking ahead, you should be able to predict what's going to happen here. Cancels. Cancels. That means on this side I have 0. Does 0 equal negative 5? No, it does not. False statement. That means I get to say no solution. So you can get a no solution answer. That is possible with a three-variable system. All right, false statement, no solution. Let's take a look at this system. Now I have a system where I have some of the variables there, and there are some missing. There's an x missing in the bottom one, y missing in the middle, and z missing in the top. I just have to figure out, what do I want to try to eliminate? Is there some equation, some way, somehow, that I can eliminate something fairly quickly? All right, let's look at the top two equations. 3x plus 2y equals negative 1, 6x minus 2z equals 4. Okay, how can I eliminate x? I can eliminate x on the top equation by multiplying the top equation by negative 2. I know what some of you are thinking. Wait a minute. Am I going to create, I'll still have three variables. Maybe. Let's take a look here. So if I multiply this by negative 2, I get negative 6x minus 4y equals 2. I'm going to copy the second equation over. 6x minus 2z equals 4. Add them together. The x's cancel. Yes, I'm going to copy minus 4y. There's no z in the top equation. There's a minus 2z in the second one. I will copy that. 2 plus 4 is 6. So now I have an equation with a y in it and a z in it. This gets us started. Take a look right here. What do you notice? Now I have another equation with y and z. So now what I've done is I have created a system where it's y and z, a two-variable system. I don't have to eliminate the x again. It's already been eliminated. So copy it over. Bring that rascal over here. Y minus 3z equals 2. Now the nice thing about this, I got a plain y. It makes my elimination easier. What am I going to multiply the bottom equation by? I have a minus 4 up here, and I need a positive 4 here, so I am going to multiply by positive 4. And when I do that, I'm going to have a new system. So let's multiply the top equation, or the bottom equation, I'm sorry. I'm going to erase that line I just drew. All right. So multiply by 4, 4y minus 12z equals 8. Copy the top equation, minus 4y. Okay, add the two together. Y is eliminated. Negative 14z equals 8 plus 6 is 14. Yes, z equals negative 1. All right, a good thing about this type of system, when you have equations now, z is negative 1. You have two equations where a variable is eliminated. We're going to go very quickly. I'm going to put the negative 1 in. And since this is a positive y right here, I'm going to put negative 1 right here. I'm going to have this. So substitute it back into this equation. Y equals negative 1. All right, so y is negative 1, z is negative 1. Well, now what? Pick a number. I can put negative 1 in for z in this equation and solve for x. I can put negative 1 in for y up here and solve for x. I believe on this one, just to show you, I'm going to use the top equation. So I will have 3x plus 2 times negative 1 equals negative 1. Oops. All right. So 3x equals positive 1, x equals 1/3. All right. So yes, you can have fractions in your answer. So our final solution on this then reads 1/3, negative 1, negative 1. Final answer on this system. One more system to do. All right, we're getting close to that 20-minute mark. I'll see how quickly we can do this. Fractions. You got to know I'm going to have them in there. Here we go. How are you going to eliminate here? What do we want to eliminate? I see in the middle here, I see a minus y and a plus y. I got opposites here with the x, and I got opposites with the z. It really doesn't matter, but I'm going to use the top two equations right now. And in fact, what I'm going to do is I'm going to just eliminate z this time. So I'm going to multiply the top equation by 2. Top equation by 2. So I have 2x and I see I made a mistake. Here we go. 2 times 2 is, yes, 4. Get the cancer right. Hey, what's going on here? 2x plus negative 2x is 0. Cancels. Negative 6 plus 6y cancels. 8z minus 8z cancels. 4 minus 4. What? 0 equals 0. What does that mean? What does that mean? All right. Again, in our other equation work, we've looked at and said, hey, that means all real numbers. We can't say all real numbers here. What we actually say is that there are infinite many solutions here. So it looks like this. That's what we would say. In the textbook, you would see some fancy writing, and it kind of looks like this. And it would look something like that. And how you read that actually is that the solution x, y, z is the member of any set of numbers that works in the equation x minus 3y plus 4c equals 2. That's a fancy way of saying infinite many. All right, so when you get done with this, these do take a while to do. You'll only have 5 problems to do. If you are really bold and adventurous, I guess I'll be nice today since you took almost 20 minutes out of your life to watch this video. If you do want to get started, you can. It starts on page 221, and the first 5 systems I want you to solve are numbers 5, 12, 17, 23, and 31. If you want to wait till class to do that, that's just fine. If you're in class watching this, time to get to work. Uh, let me know if you have any questions. Thanks for taking 20 minutes to watch this.